Hello students. Now we are starting with semester 2 subject called CS02, CS07 data structure using C language. I am going to introduce the entire syllabus in front of all the students. As per the prescribed syllabus of Saurashtra University, total there are 5 units are available in this entire syllabus. Unit number 1 is algorithm analysis as well as the advanced concepts of C and introduction to data structure. This chapter is little bit lengthy as university has merged two different concepts into the single unit, that is algorithm analysis as well as the discussion of advanced concept of C with the introduction of data structure. Without wasting more time, let's start with the same. Obviously, we are starting with algorithm analysis first, but before that, justification of the title should be clear. In this particular subject, we have to implement the concept of data structure using the C language. Yes, we can implement the concept of data structure with other languages also like C++, etc. But clearly indicates in this syllabus that we have to implement the concept of data structure in C language. So we'll use the concept of C for implementing various concepts of data structure. So first, it should be clear that what does a data structure means. So data structure is a one type of process for arranging the data in a proper structure. That's why the name is given called data structure. Let me repeat the definition. Data structure means it's a procedure of arranging the data in a proper format, which is called as data structure. That means whenever the user enters their information, they are free to enter their information in any sequence. Once the entry is done, once the input is done, program rearrange all that inputted data in a proper format and shows in a proper sequence. That concept is called as data structure. So these arrangements can be done by writing the logical sequence, which is called as program, and that arrangement can be done in different ways. The techniques we have to learn in this particular subject through the concept of programming in C. So that's why the title of the particular subject is given called data structure using C language. So let's start with algorithm analysis. Here first we have to introduce the definition of algorithm. What is algorithm? So as per the technical guys and the experts of programming language, algorithm means stepwise instruction given which shows the actual flow of program for designated output, that is called as algorithm. Again I am repeating my words. Algorithm means set of instruction, set of logical instructions given for executing the proper sequence of program, that is called as algorithm. Let me show you one definition onto the screen. As written over here, to make a computer do anything you want, we have to write a program, and before writing the program, steps for executing that program should be written onto the blank paper that executes the program properly, and this method is called as algorithm. Actually, this is the mechanism which we have to plot onto the paper before writing any logical instructions into the programming in C. That is called as algorithm. In this logical sequence, actually it demonstrates that user how user instructs the computer for executing the logical sequence in such a way that the output can get without wasting more time and spending useless efforts. So that's why algorithm need to be right first, and then we can go for a logical implementation. The algorithm is the basic technique which is used to get a particular job done. Let's follow one example which demonstrates, which justifies the definition of algorithm. For example, I am taking one algorithm for taxi. Suppose we want to get the taxi for traveling ourselves from one source to another destination. That what sequence we have to follow? First we have to go to the taxi stand, then we have to get into the taxi, and then we have to inform our driver for the address where we want to reach. So this is actually our sequence. Step number 1 is go to the taxi stand. Step number 2 is contact the taxi driver. Step number 3, inform that taxi driver for the address where you want to go, and then your job get done. For example, suppose we want to call some person, then what we have to do? We have to open our phone, then we have to dial the number, and then we have to press the button called a green button called call. Ultimately, the mobile company will get connected to that particular person. So this is a one sequence which we have to follow for getting our job to be done. Here we can take another example, that is the bus algorithm. Step number 1 is outside baggage claim, catch the bus number 70, transfer to bus 14 on Main Street, get off to the particular street and walk 2 blocks north to my house. That means, suppose we want to go to the particular place through the bus, then first we have to go to the bus stand, then second, from the various bus we have to select the particular bus which reach to the our desired destination city. Then we have to, step number 3, we have to sit into the bus. Step number 4, we have to collect a ticket from the ticket collector. Step number 5, we have to wait for the certain time till that particular bus will reach to the destination, and then finally our job gets completed. So this is a logical instruction that we have to follow for traveling ourselves from one source to the another destination. That is called as algorithm. Now during this algorithm we will face the two complexities. That complexities are called as the time and the space complexity. Now what does it mean? Actually these are the two separate topics, time complexity as well as the space complexity. First we will discuss about the time complexity. Time complexity is dependent on the time of executing the particular algorithm to the specific time. That is called as time complexity. Say for example, suppose we want to travel from one source to another destination, but it takes longer than the desired time. The problem that we will face is called as time complexity. And the space complexity means unnecessary usage of the resources for the day. For example, suppose we are traveling from source to destination for the single day and we are packing the bag for the cloth of 10 days. That occupies unnecessary space. That demonstrates the functionality of space complexity. Now this time and space complexity should be maintained for writing the proper algorithm, which saves the time as well as the space. Here what I want to say is, let me show you over the notepad. Say for example, simple code here I am demonstrating, hash include stdio.h, hash include console input output dotted void main opening bracket with closing bracket. Here I am writing four variables like a, b, c and d. Then there is a one basic function called clr then a simple function called enter your number, scanf %d comma ampersand a, printf enter your second number, here this is enter your first number, then scanf %d comma ampersand b, c is equals to a plus b, printf %d comma c, get ch, and the program completes. We know the output of this particular program. It will add the two numbers and it stores the output value into the third variable called c, and c will be printed onto the screen. That means suppose we enter the two number called 2 and 2, it will give you the 4 as an output. But in this program, one variable is unnecessarily occupied which creates the space complexity, and that variable is called as d. Remove that particular variable or don't assign that particular variable while creating the program. This thing is demonstrated as a space complexity in our program, no doubt. In semester 1 we are just writing the program of 10 to 20 lines or maximum 15 lines, but in data structure which might increase up to the hundreds of lines. So at that particular time we have to keep in our mind that whatever the variable or whatever the necessary variables that we require need to be declared, and before assigning any variable just do your rough work through the algorithm or a flow chart which reduce the creation of space complexity. So this time and space complexity should be considered before writing any programs. Let me again repeat my words. Time complexity is related with the time of executing a particular program. That means the execution of program should be done within the time. That demonstrates the time complexity. And the space complexity means the number of variables or unnecessary use of variable might increase the space complexity. Try to reduce it as much as possible. That means before writing the programs, create an algorithm for the same which reduce the time as well as the space complexity. Now into the analysis of algorithm, that is into the title of unit number 1, these are the two techniques that is called as time and space complexity is introduced for writing the effective program. So that's why lines are written over here. In computer science, the analysis of algorithm is the determination of the number of resources such as time and storage necessary to execute them. Most algorithms are designed to work with input of arbitrary language. The efficiency of running time of algorithm is stated as a function related to the input length to the number of steps, which is called as time complexity, or the storage complexity, which is called as space complexity. So very shortly, here I have demonstrated the complicated words of data structure in 4 to 5 lines. But in short, suppose we want to make it simple, then we can say that time complexity is related with the execution of algorithm with a specific time that we can reduce by writing less number of storages, and storages are related with the space complexity, which reduce the total number of lines that we have created for the program. And here I have demonstrated the same thing by writing a one simple program which add the two number. In this program, as you can see that here I have declared unnecessary variable which is called as d. No doubt this program is of I think 10 lines, but if this particular program is of hundreds of lines, then it increases the total execution time, and even it unnecessarily occupies the space, which introduce the two concepts of data structure called time as well as space complexity. Let's go ahead. This time complexity as well as the space complexity can be demonstrated through this particular graph. We are not going in detail about this graph, but let me tell you the two things. In this particular graph, you will find the two directions. One is the positive direction and another is the negative direction, where this particular graph is filled with dark circles. That means it occupies the maximum number of time utilities, that means it will occupy maximum time for executing that particular program. That means if we have written unnecessary loops or the loop with such type of condition which never terminates, increase the execution, which actually creates the problem of time complexity by increasing the execution time. Now the question comes in our mind that how can we reduce this time complexity and space complexity problem theoretically? So for that, we have to introduce the two notations, that is called as big O and big omega notations. So I think this is the sufficient dose for today's lecture. In our next lecture, we will introduce these two notation called big O and big omega. I understand that this is a little bit difficult to digest that whatever we have taken in this session. So in next lecture, again I will repeat the definition of algorithm. Again I will reintroduce the two complexities called time and space complexity, and then we'll go for the solution of time and space complexity through big O and big omega notations. But before that, I suggest all the students listen all the words of today's lecture twice a day. That will help for understanding the advanced concepts. Thank you very much students for listening me, and have a nice day.